All right, this is so fun. We get to talk about all the greatest hits. Um, okay, well, we're looking at Skynet now. So we just talked about Cyberdyne and the problems and good things about it. Um, in that era, almost as soon as I got it out there, the question came up, is there a way to make this easier? Because if you look at that fixture, it was kind of like a bunch of CNC cut blocks and that sort of thing. And it was a little, it's not something everybody could produce just the way it was. And there's a lot of hobbyists out in bike land that want to make bikes and they want a good fixture. And especially from my perspective, there's there's three things that shouldn't be wasted when you build a fixture: your money, your time, or your space. So a novice that's entering into this really needs to be careful, and they usually aren't, about which direction they go and how they're going to go about this whole process. They're generally getting pretty bad advice from some guy on the internet. And, you know, I have the luxury, or not luxury, but because I've been involved in the world of making bikes in some way or close or proximate to it, but also metalcraft and manufacturing since about 1990, um, and have worked with or talked to or hung out in the shops of fancy name people that have been at this too. Some that are very, very good at what they do and have made more mistakes than any of us put together. Um, you start getting a different perspective than an influencer on YouTube or some guy on a message board that professes to be um, some kind of expert. Um, so when I was convinced to redesign the Cyberdyne in a way that maximized the ability for, let's say, perfect example is a high school kid with maybe some access to a manual mill and manual lathe and not very much experience using those tools and not a lot of money, um, which in a way could describe almost every budding frame builder. And so how would we solve those problems in a similar way? Well, I mean, my general advice in the current era for anybody is invest in a welding table, a proper fixturable welding table. It is by far one of the best ways to spend your money if you're looking at entering in this world, just because it can be leveraged so powerfully in so many different ways and it's extendable in so many different ways. So that's a real wise place to spend a lot of money. Um, but a lot of people can't do that, and I get it. But what they might have access to is a wood shop or a sheet of MDF from Home Depot, and they can make a torsion box with MDF. Here's some 3/4 MDF, and it's been cut with a raster, let's say on a CNC router table, which those are fairly common in small towns even, Maybe you got to do a favor, get access to one, but I mean, you could lay this out and do this by hand, and it would be still pretty darn good compared to some other fixtures. But anyway, just some basic cutting of wood and gluing together type of stuff will produce a proximate equivalent uh, welding fixture if you're broke. Okay. Now, I did this after the Cyberdyne, so I'd learned a few things. One of them was I wanted to get away from the pinning out of the positioning. I wanted to slide. So, of course, we go to 80/20 first, and we like 80/20 because that's exactly what it does well. But we need to position, if we're going to bolt down some 80/20, we need a way to position it. Let's open up this rail here. Perfect example. Are we recording? Yep, we're recording. Okay. Um, so if you notice here, I have wood screw holes. So you could just plain old, I mean, if you're just going to be gangster AF, you could just cut some 80/20, put some wood screws in there. You clamp this thing in position and you double, triple check that it's confirmed and it's good. You can just screw this down and boom, you're done. In fact, you could do it with a whole length and do your seat tube and your head tube with one bar each, so that that was effectively going to be your horizontal datum. And that's one way to quickly fab in some just dead nuts precision. But be careful. But it can be done. And so then you don't even have to do the raster. You can just bolt up, with the a few rails and a hole for the bottom bracket. You've got yourself a frame fixture with some 80/20. But anyway, I engineered these holes into the 80/20. They're 3/4 inch diameter and 5/8 through, and they're machined with a 3/4 inch chamfering end mill. So you immediately get that 45-degree chamfer there, and that essentially replicates what the top of the welding breadboard is like. And in cahoots with those pins that I talked about, let's not change anything. Um, oh, by the way, the bike on this fixture currently is the MiG 31, the Firefox. That was a short-lived bike. Um, that's where we discovered how thin you can print or how thin you couldn't print. Um, anyway, it was pretty until it wasn't. What happened? Okay, there we go. So yeah, so then there's these pins that you have to make, and this is the fussier part of this construction. Where is it? Oh, it's on this side. Uh, Come on. Oh, they're on the rail assembly. Let's get into the rail assembly. There we go. That's how we should have done this to the start. Just open up a rail assembly. Okay, there we go. Much better. So yeah, there you go. You can see the wood screws, all great. And but then if you're using a raster, if you're using a weld table or you've made a raster on an MDF torsion box, and you can get these pins made, which you can make on a manual mill. They're not too hard to make. I mean, sorry, on a manual lathe. And it's just a countersunk for that. It bolts that down, and you can move that around anywhere on a breadboard now. So that's probably the toughest thing about this fixture, is getting these pins made, which I don't think is too hard. Um, and also people could group together to make pins, that kind of thing. But you can also see, boom, screwed down some screws, and these are special screws for particle board to, what is it? This is the McMaster number down here. Flathead screws for particle fiberboard or fiberboard. Throw some glue in there if you're going to make a permanent thing. So that's cool. I just hid that plane, so I'm gonna save it so it's just out of our hair. Love playing with the rails. Woo-hoo. Oh, so some people are going to be wise and they're going to say, oops, hey Pete, why didn't you just use 80/20 rail stuff, motion stuff? So here's a piece of 80/20, and I like the low profile stuff. I think it's nice. You get the heavyweight stuff too. This is the bearing material that they sell with their stuff, but if you notice, it's got significant play in that. Now, worst case scenario, you could use that, but it's not that great. I mean, they have motion control parts. Ugh. There we go. So here's a 80/20 motion control type thing. But I don't believe that these are produce the precision we're looking for in this environment. You could end up making something that used it, but I don't think that's wise. Anyway, so I make my own system. Let's open up this angle plate that's largely a piece of aluminum plate with a bunch of holes drilled in it. Okay, there we go. So because we don't really have the thick material or the CNC stuff, we set our clamp down angle stuff down here. This isn't for precision placing, this is just for clamping. We still end up with a cosine bar made by that pin, um, but we're sliding along the 80/20 using these. You can get a full length of key stock. Here we go. So you can make custom T-nuts with this. I say order length. You can get individual pieces, but if you want to stop a lot of racking, doing a pair like this is good. They sell cheap plate ones and everything like that, but if you can, make them out of the proper stuff, and you can buy these in lengths when you do your orders. Just don't forget. So that's really the right way to do that. And of course, when I made this, all the documentation was shared online for making one of these fixtures, so you can look that up. Anyway, so I cut some Delrin blocks here. They get pinned in place and clamped down. And that essentially is your fixed datum of the slide. And then on this side, almost the same part, different clearance, but then you screw in a spring-loaded set screw type thing. What do they call them? Let's see for the proper name. Ball nose spring plunger with stainless steel ball. So yeah, and all that's supposed to do is provide a little bit of spring tension on one side, because what we want to do is treat this face as our datum for the slide. This clamps it down, this pushes it in the other direction. Worst case scenario, if you overpowered, it bumps up against this Delrin here. Nice and slidey. Okay, and on top, we don't need that because we only need one rail to make a linear positioning, and these clamp. So super solid, and it's all nice, pretty easy to get to. Here's your pin for the pivot, just a counter bore in there, and then you're in business. So not a hard plate to make, and that was pretty cool. I mean, it's a real job, but I think a novice could make it if they have a DRO, especially. And make a little cart for on top of the 80/20. These are fairly simple parts. Let's look at that. The SKYNET 2 gets some really fancy versions of these because that's a different thing. Anyway, so there you go. Pretty simple way of tracking on an 80/20. There are other ways of producing precise movement on any 80/20 rail, but this is actually pretty darn good. And we just pin out. And of course, on this design, and this has been improved, like that's the problem with this SKYNET is it is highly improved on the next one. These pins are 5/8. We want to make sure. Remember, was it the last video I said about, if you spend $1, you want to get $1.50 back, not 75 cents? If I'm going to make a puck, I want it to drop into my welding table too, not just my fixture, because there may come a point where that's a setup that I might want. So I'm looking forward to future setups of like, hey, wait, something has to hold this. Why not make it 5/8 or 16 millimeter, whatever you're working with, that's fine. But this can be used in another way, okay? And I think that's a special puck for that. Anyway, of course, I've got the rails on there, some various just spacers. It's nothing too complex. To bring the cost down and the ability to machine it, I made this multi-part standoff with some aluminum tube. Let's change the transparency. So this is aluminum tube, and it sits on, and the column itself clamps through this lower plate. Now that might seem like, why are you making it harder for me if you're trying to make an easy to make fixture? Well, the reason for having it sit on this is this has got a very broad base, and that spreads out the load. So if we're using MDF, we can still end up with an extremely rigid stanchion coming off of that table, and it won't mar up the table if we start really leaning on things. Now, there are limits to what you can do with the MDF, but this is the whole intention here is we can bolt to a welding table or MDF, and we still have significant purchase down at the bottom. And then, of course, we step up to it. But the diameter of this aluminum, and the documentation says, if you can increase the diameter, you should. It's just a lot of lathes people have in common circulation might not be able to hold a through piece of too great of a size. So this was kept down to a minimum. I would prefer if that was larger. And then, of course, we're still using 80/20 just to make those V tube holders there. Down here, we switched to a 3" by 3" 80/20 column, and then we pin in a bracket that for some reason ended up with the wrong configuration there. I'll fix that later, but anyway, it bolts up. And a nice little release mechanism here, so this clampy doodle stays tracking with a little spring pin there, so it slides back, it doesn't wonk out, you know, that kind of thing. Similar sort of arrangement with that spring detent Delrin slide here, and we have a readout here for our position. We reference the edge there for the seat stay position. I think the head tube probably references here or up here, probably up here maybe. We have a tiny little itsy bitsy machinist square, helps us mark this position. Could probably use it elsewhere. And then up here for the top of this plate, we have that, you know. And of course, all these scales and these rails can be located wherever you tend to work. Like if you do a lot of work just on children's bicycles, you might have a set of these that are just for children's bicycles that are they're in the range for that. And then you might make pro downhill or enduro bikes that are huge, and they have a whole different set of rails just to make it easier on yourself, depending on what you like to do. Here's an example of that gear puller type mechanism. Now, one problem when I wanted to make this easy for people making it, the problem was that cone to cone type setup that I did before. I don't think novices are going to pull that off. That is a little over their heads in terms of ability to produce mating cone angles. Maybe they can do it. That'd be cool. And I make a note in the documentation. If you can, you should. But this is a cylinder in there, which, yes, it will bind, but we end up producing this gear puller that we can pull these things apart by making the tool that we're going to need to ahead of time. Okay, so that's kind of cool. And again, this is a well-documented fixture already, but we're just pointing out that we solved a couple problems from Cyberdyne. We advanced some of the cause, and this is all easy to make stuff. And several people have produced a SKYNET fixture. It's pretty cool, and just simple enough, making a torsion box, drilling some holes, or just directly attaching. This is easy stuff, and there you go. You could even, if you have a laser or even a router, you could have all these hole positions marked out in an XY configuration, like a little crosshatch for each one of them, and then drill it on a drill press without having a milling machine, and then you could probably get, well, you got the counter bore, so you might have a counter bore tool. Um, but you could get pretty darn close. I mean, and another thing that's really cool about these plate designs is, let's say you produce this up here, this head tube holding area, and you're just a grum and you don't know anything and you got bad tools or something like that around you, and you produce some hokey ass crap, and you can make a bike, great. But what's cool is you can come back later and improve on that. But it's, you're just improving that one area and fixing that one area. You don't have to make a whole new fixture, you know. And in a way, what's really helpful here is, yeah, some people are going to suck at it when they start, but here you can, you know, say you do this plate crappy. Um, Maybe you come back to it a year later and make it much better because now you know, now because you're a cool maker, bro, and you make your own bikes, now you're talking to the cool kids and you got a buddy with a CNC mill or something like that. Because that's how life works. You know, once you get in the game, you start talking to other people that play the game. And, you know, this is a platform where you can slowly improve everything as you go, or your pins sucked and now you know a dude, or you're going to do a group buy or whatever. So yeah, this is a cool fixture. I really was stoked when I produced this, and wait till you see the improvements. Oh my goodness. Okay, what else? Anything I'm missing here? We got a nice little slide, column, blah blah blah. Oh, if you notice, I made this. This is for if you have a CNC machine, you can make this nice little clamp with slots in it, because that's from curved slots for a novice machinist type thing. Like this will help you, you know, make life easier versus on this side, it's the, I just can do X, Y, and we cut that slot at an angle and it's a little looser, but it works just fine. And it's just a rectilinear profile, you know. Oh, and also this has drilling so that you can close in the spacing. Let's say you don't have the room on your board for a second row up here, you can choke it up down here, which is nice, you know, because sometimes you run out of room. And there we go. Okay. Um, cool. So SKYNET, that was quick, but it's in lots of ways, it's actually an improvement on CyberDye. Um, so that's cool. It gets cheaper and easier as we go. We're developing, right? So we'll talk next about the Whopper because Whopper was real cool.